The recent film Don't Look Up, starring Leonardo DiCaprio and Jennifer Lawrence, follows the story of two astronomers who have spotted a planet-killing comet on a direct collision course with Earth. The film plays out the astronomers' struggles to tell the world and convince others to act. Here at The Naked Scientists, we want to know the reality of what these objects are, how they are found, and what methods are being trialled to ensure that Earth is protected from future collisions. I spoke with Hugh James, Fellow of the Royal Astronomical Society, to find out more. First of all, Hugh, we hear about lots of objects that fly around in space, but can you tell us the difference between a meteor, an asteroid, and a comet?
Hi, Katie. Sure. A few key differences between them: the material and the location. Meteors are the shooting stars we see in our night sky, little pieces of dust that burn up in our atmosphere. Going out from there, we've got asteroids. They tend to be made of rock and metal and orbit the sun in a few ways, but a large proportion of them have joined the now famous asteroid belt. Then comets are the dirty snowballs. They can have huge orbits like Halley's Comet, which goes all the way out past Neptune before heading back to us every 75 years.
These meteors don't sound too dangerous to me. So if it's the asteroids and the comets, these larger bodies, that would cause damage, how can we spot them?
So we're looking for objects called NEOs, or near-Earth objects. It's an object that's large enough to pose a threat to Earth. At any one time, there are a few survey telescopes looking at the sky, taking a few pictures over consecutive days, then comparing them to see if anything moves. Luckily, that's all done by computers now. But to make sure it's what the computer thinks it is, astronomers from around the world make the same observations, meaning the amateur astronomy community plays a big part in this. Once we have the coordinates, velocities, and orbits for the object, they get sent into the database at the Minor Planet Center to see if this object is already known. If it's new, then some lucky researcher will probably have it named after them.
How often do we find new comets or asteroids?
We're currently finding around 3,000 near-Earth asteroids per year, and about 28,000 in total so far. We're finding more per year because, well, technology is getting better, but it doesn't mean that there are more hazards out there. In terms of comets, we only see those long sweeping tails when they get close to the sun, so we get caught off guard from time to time.
What size would be considered dangerous?
NASA monitors everything over 140 meters, what they perceive as a quote-unquote hazard. Luckily for small objects, they regularly just burn up in our atmosphere. But NASA predicts if an asteroid reaches Earth and it's much less than 1 kilometer in size, it'll have devastating but only local effects. Anything above 1 kilometer could potentially have worldwide effects. The one that struck as the dinosaurs were dying out was around 10 kilometers in diameter for perspective.
Gosh, that really is a huge asteroid. But let's say we spotted a comet or an asteroid that's a bit smaller, around 1 kilometre in size, that's headed directly for Earth. What can be done?
Well, option A, send Bruce Willis and Bennifer to land on the asteroid and blow it up with a nuclear bomb. But other options do exist, and we're only just starting to bring them into reality from the world of sci-fi. The recent DART mission from NASA is literally trying to knock an asteroid off course by crashing into it. Or as NASA put it, demonstrate asteroid deflection with a kinetic impactor. The good news is that at the massive distances involved, you only really need a small bump to send it way off the path of Earth. But obviously, the bigger the asteroid, the bigger the bump you need.
And when is this DART mission due to strike?
Well, it only got launched in November, but it's planned to arrive at asteroid Didymos and its moonlet Dimorphos in September. It's a double asteroid, hence the name Double Asteroid Redirection Test. So I'm excited to see if we're able to affect the course of an asteroid in any way.
And if we aren't able to redirect it, what happens?
Well, deflection through impact is probably one of the simplest and least dangerous ways of deflecting a hazard in space. But there are more complicated ones, including gravity tractors, solar sails, asteroid laser ablation, literally shooting lasers at it. And of course, if none of them work, we're back to Bruce and his nuclear bomb.
This sounds all very sci-fi, and I hope I don't ever have to witness the need for these technologies to be put to use, but I am glad to know that there are multiple ways to protect our planet from these collisions.
Well, let me put it this way. This isn't a case of if, but when. So when it does happen, you can sleep soundly, Katie. Don't worry, innovation will hopefully help us out.
Thank you, Hugh, for helping us understand how we are protecting our planet from potential incoming asteroids.